Hello, today I will talk about the Lab 4 determination of gravitational acceleration. Let's move in with synopsis and theory. SHM, simple harmonic motion. A body is considered to move in SHM if it follows the following condition. First, the acceleration is always moving toward one fixed point and within the line of its direction. Second, the acceleration is linearly proportional to the distance and the fixed point. The maximum displacement for a particular body from a fixed point is called amplitude, and the time taken for a complete oscillation is known as periodic time, T. For that, SHM, the relationship between T and gravity G is shown in this, whereby L is elongation of spring, length of string, and G is gravitational acceleration. Next is frequency. The number of cycles met with periodic time. The relationship between T and frequency F is equal to 1 over T. The relationship between F and G can be shown as F equal to 1 over 2 pi square root G over L.
So for the lab 4, determination of gravitational acceleration, which is the part A, is the mass spring system. So the first step is we have to copy this link and get the link, copy and paste on the website. Okay, by using the virtual mass spring system. Open it and read the next step. Second step is click on the play mark and choose lab, and I choose lab 1. Okay, for the next step is step 3. Set the spring constant to default. Take the displacement or natural length and set the damping to known. By using a ruler provided, measure the length of spring without mass. Okay, so what I have to do is take the displacement and the gravity is default and set the damping to the known and get the ruler to measure the spring without mass. So I got 45, 6, 7, 8. Okay, put the ruler wisely properly. So I got 48 cm. So how do I get a 490 millimeter? Because we want a millimeter. So 48 divided by 10 to get a millimeter. So for the number of spring without mass is 480 millimeter. Okay. So for the next step, read the next step is step number 4. Hang a mesh, refer to table 1. Okay. Table number 1. At the end of the spring, measure the elongation of the spring. Do the displacement of the mesh. Okay. So what we have to do is put the mesh on here to 50 gram on the table by the first row. So the elongation we have to measure is on here. So what we can see on here is 5, 6, 7 cm. 7 cm the elongation of spring. So we have to convert to millimeter, which is divided by 10 and 70 millimeter. So read the next step, which is step number 5. Pull the mesh downward and measure time taken for a predetermined number of oscillation by using a stopwatch provided. So what we have to do is take out the stopwatch and the number of number of oscillation is 25. So we have to counting 25 and let the spring go first, and we have to count until 25. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 18 19 20 21 22 23 4 5. So I got 13.80 second. So this is, I just want to show, but in my lab discuss and I got 13.90 second. So it's okay. We got human got a human error, so we can get the answer accurately. So we have to read, and we have to counting 25 and get the time third times, and counting third times, so we get the average is 13.93. And how do I get the predict time is, which is I have to calculate the predict time. The formula is here. Time taken average over number of oscillation is, I get the first row is 0.5572 predict time, and the t square second is, which is we have to get the time and t square, which is I got 0.3105 second. So this is how, and this is the flow to do it the experiment for mass spring system. Thank you.
Hello and hi guys. We continue about part B, about the pendulum system. Firstly, go to website that's given in the lab. Okay, after that you click play, and then you choose lab. Okay, in this web you can see they have a length, mass, gravity, friction, and also have a stopwatch. Okay, and then for this lab you need to set the mass of 0.50. Okay, and then tick at stopwatch and set a friction to none, and then set the length of the string. The length you need to refer according for table 2. For the first one, the length of string is 0.10. Then you need to set for the length is 0.10, and then click on the mass and bring up until 50 degrees, and then you release. At the same time, you need to measure the time taken using the stopwatch until you need to count 25, because in this lab the number of swing is 25. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. Okay, after 25 count, you need to record your data in table 2. We take the next example is length of string is 0.20. Click at the length and set 0.20 and click at the mass until 50 degrees. And then you hit the button, and then you count until 25 swings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. And you stop the stopwatch and record your data in table 2. After you fill up the time taken for take 1, take 2, and take 3, and then you need to total the average. For this 0.10 length, the average is 16.73. Average is 16.73 because time taken 1 plus time taken 2 plus time taken 3, and you divide by 3, and then you get 16.73. Okay, for the next is period times. For the period time, this formula is time taken divided by number of swings. For the example, for the row 1 is time taken average is 16.73, and then you divide by number of swing is 25, and then you get 0.6692. For the t square, you take the t is 0.6692 and square by 2, and then you get 0.4478.
Now we enter the questions section. Question 1. By using Excel, plot a graph of t-square versus elongation of spring L for part A. Then determine the slope. This is the table that we have did earlier. So they say plot a graph of t-square versus L. So we just take these two columns and we plot the graph. We put it in Excel. We will get a graph that looks like this, where the y-axis is t-square and x-axis is L. So then they ask us to calculate the slope. How to calculate the slope? We calculate by using gradient. We draw a big triangle and we take the first value and last value. So the gradient will be y2 minus y1, 1.997 minus 0.3105 over x2 minus x1, 0.48 minus 0.07. You will get an answer of 4.113. From this graph, you can see that it increases linearly because it did not pass through 0. For part B, plot a graph of t-square versus length of string L. Then determine the slope. This is the table we have did earlier. So we take these two columns where y-axis is t-square and x-axis is length of string L. You will get a graph that looks like this. Same, y-axis t-square, x-axis L, and use a big triangle to calculate the slope. So you know that y2 minus y1, 4.368 minus 0.4478 over x2 minus x1, 1 minus 0.10. You calculate, you will get 4.356. The graph is also increases linearly because it did not pass through 0. Moving on, question 2. Determine the value of gravitational acceleration g for both situations, which is part A and part B. The formula given to calculate g is t equals to 2 pi times sub L over g, whereby t is period, L is the length, and g is the gravitational acceleration. We play around with the formula, we will get g, gravitational acceleration, equals to L length times 2 pi over t period square. So for part A, first we have to calculate the t average and the L average. By using the data we have did earlier, we just calculate the average. and then we sub in the formula. G equals to L 0.275 times 2 pi over T 1.0276 square, and you get an answer of G gravitational acceleration equals to 10.28 meter per second square for part A. Now part B. Same, we calculate the T average and the L average. Then we sub in the formula. G equals to L 0.5167 times 2 pi over T 1.422 square. We calculate, you'll get an answer of G gravitational acceleration equals to 10.09 meter per second square for part B. This is how you do question 1 and question 2.
Question 3. Compare the value of gravitational acceleration G from part A and part B with the theoretical value of G and give the percentage of the difference. Theoretical value of G is given as 9.81 meter per second square. Okay, this is the formula that were given in the lab. For part A, the percentage difference is negative 4.79%, and for part B is percentage difference is negative 2.85%. Question 4. From this experiment, what are the main factors in determining the gravitational acceleration G? Discuss your answer. Okay, the answer is mass and wisdom. Why? Because the larger the mass, the more gravitational force of each object exerts on the other. And the larger the distance, the less gravitational force each of object exerts on the other.